Today's session is on IBM Security Guardium. In this session, we'll discuss one of the main features within IBM Security Guardium data protection, which is called Discover Sensitive Data. We have today with us Shashi.
Next, I'll quickly show a simple demo. So this is the login page for the Guardium data protection. So let me quickly log in. And I was mentioning in the, if you remember in the data lifecycle chart, I talked about most of the features that are available in the Guardium data protection. So you can see the discover and classify here, the vulnerability assessment, and the monitoring your data and so on. But for today's demo, let's just stick to this discover and classify. And as I mentioned earlier, we have some predefined templates, right? So for example, if you want to be compliant with GDPR regulations, we have this predefined template for you. And if you can, all you can do is you can just reuse this template. And you can see when you come to the rules part, we have already selected the 33 different rules that are relevant for GDPR regulations. And also, if you take an example of CCPA, which is California Consumer Privacy Act, there you can see we have already selected the 50 different rules that will apply for CCPA. So for today's demo, I don't want to use any of these predefined templates. Let's create a new scenario so that we can understand better. And from the demo till the next slides I'll be talking about, I'll be using an example of finding the Visa credit card number. So let's use a simple example here. Okay, so let's stick to Visa credit card number. And in the description part, I can give some description or leave it blank. And let me create a new classification policy which is relevant for my Visa credit card number. Okay, and this is something that we use for tagging violations down the road. So I'm going to leave the category as sensitive and the classification as sensitive too. And this is the one I was talking about, the structured and the unstructured data. So for today's demo, I'll be using DB2 data source. So it'll be a relational database. And the second thing is the what to discover part. This is where the magic happens, right? So we have tons of predefined rules here. So you can pick and choose anything you want. So for today's demo, I'll be just using the predefined Visa rule. Now, let me quickly edit this rule and show what's there. So the name here, it says Guardium credit card, and category and classification is sensitive. And this has a typical rule criteria, and some of the advanced options here, and I will be talking over in detail about the bunch of these options here and how we can leverage these options to maximize the accuracy of the search results and minimize the false positives, right? So by default, you could just run these, right? These are reasonable parameters, but again, I'm not going to change anything in the advanced options, but we'll talk about the trade-offs in the upcoming slides. For now, I'll check this calculate confidence score. And once the results are back, I'm going to talk about what this calculate confidence score is doing, right? So let me save this rule criteria and let's go to the next section. This is where the where to search part comes into picture. So this is how a data source definition looks like. And it's pretty simple, right? So we do need your username and password credentials to connect to your data source, and the rest of, and this will be saved within the Guardium environment, by the way. And also a standard things like the host name, the database name, and the port number. And we can do a quick test connection to make sure the connection happens before we run the classifier, right? And also, you can select any number of data source definitions here. We are not just restricting to one. You can select one or many. And an easier way is also you can create a group of these data sources. For example, I can group all the DB2 instances into one group and just select the entire group here. But for this demo purpose, we'll just stick to one data source so that we get the results faster. And we did the where to search part. So let me save this scenario so that I won't lose any data. Now, let's run this. And as I was saying, we have some advanced options about the sample size and the sample type. So I will be talking in detail about the sample size and sample type in the further slides as well. It's going to take a less than a minute to run this and gives us the results. So let's wait. Okay, so we saw there were two matches here. So this is the report results that I was talking about in the output. So it is a flat list of tables, columns, what's the table name, and the credit card number was found, the Visa credit card number was found in the column name called credit card, and what rule that it was matched. And also I was talking about the detailed comments that we gave here. It's like what the rule that it matched and what was the search pattern it was used, and other search criteria options that you had selected in the rule criteria. And also, if you remember, I had selected the calculate confidence score. So here it is giving you as 48%. So what essentially this is saying is out of 31 records in that table, 15 were a match, right? So that is what it is calculating it for you. Now let's see the second row here, which is also in the same table personal, but a column name called policy number. So now it also matched the Visa credit card rule. And if I am looking from a DBA perspective, right, I'm pretty sure that the policy number cannot have a Visa credit card number there. And if you look at the confidence score here, it is only 9%, meaning only 3 of them were a match out of 31 records. So for sure, I know this is a false positive for me. So there could be a policy number that matched the Visa credit card rule number, right? So this is an example of how a false positive looks like. So now I want to stop here and get back to the presentation so that I can talk about the advanced rule criteria and how we can improve the accuracy of these results. And later we'll come back and talk about how we can manage the false positives. So now, as I said earlier, organizations are bombarded with a lot of these false positives based on how loosely or strictly you define the policies, right? So the wider we cast the net, more likely we'll find potential sensitive data. And this will increase false positives and will affect the classifier's performance. And also the person who is reviewing the results will have to go through a lot of these false positives and take some action on it, right? So in my demo example, it was only one, but if it were like hundreds of false positives, then it becomes a manual process for somebody to go and review it. But if you narrow or tighten the net, then more likely it will reduce the false positives and improve the performance. But there is a high probability that we will miss some sensitive data, right? So how do we tip the balance? So for that, we'll have to ask some of the questions ourselves, like what are we trying to accomplish here? What are our goals are? And what data are you trying to find? And what are you doing with the data? And what is the timeline you're looking at, right? So the better understanding of the rule parameters and rule options and understanding some of the data and its schema can influence the adversity of the rules that you define. So also we encourage you to talk to your DBAs and application owners so that they can provide information about the kind of data that is involved, and that will help you define the rules and find the sensitive data in a more efficient and effective way. So let's drill down and understand how rule criteria can affect the accuracy of the results, right? So notice this is the same section I briefly showed in the demo, and we'll be talking about the items that are highlighted in yellow with some concrete examples, okay? So all these fields you are seeing here are nothing but filters, and each additional filter that you add filters the data even more, and that will allow you to narrow the scope even more. Okay, so let's talk about the first rule criteria, which is the search expression. And the search expression is pretty much a regular expression, right? So if you have the knowledge about how your sensitive data is stored, then you can optimize this regular expression, right? In the first example, if you want to find the Visa credit card numbers that is stored in the raw format, right? So you can have a simple regex like starting with the number 4 and followed by 15 digits, and You can see then any number that match this regular expression is a match, right? Now, you've also seen credit card numbers that are stored with a space delimited or a comma delimited or a hyphen delimited, right? So in these cases, you can use the regular expression as shown in example 2, but this regular expression just widen the option. So you just widen the net. So there will be a lot of false positives as shown in this second example. So the question is, how can you improve the accuracy of the results, right? So that is where meta characters can help, where a caret symbol can match at the beginning of the string and a dollar symbol can match at the end of the string. So as you can see in this third example, a lot of false positives were eliminated just by using this meta characters, right? But there could be a case where your 16 character credit card number can be stored in a character field of 19, right? So then there will be a 3 additional blank spaces appended. So in those situations, you might have to fine tune your regular expressions. And that is why it becomes important to talk to your DBAs and understand the table and the schema structure. So more you understand, you can optimize your search expression. The next, let's talk about the minimum and the maximum length filters. So essentially what classifier is doing is it is searching the columns and you can specify the minimum and maximum column width. And you're only going to search the columns within that range. So taking our Visa credit card number example, we know it is a 16 to 19 characters, right? So ideally, we would specify the minimum as 16 and maximum as 19 so that we can eliminate all the false positives. But however, if you don't have the knowledge of your data, so if your credit card number is stored in a varchar 25 field, then classifier will miss it because it is greater than 19, right? So if you're not sure about how the data is stored, don't specify the maximum number, right? So again, it becomes important to talk to your DBAs and get to understand the data so that you can optimize better. Next thing, let's talk about sparse and disparate data. So let's talk about the way the data is stored and what is it stored with, right? So again, you're trying to find the sensitive data and even one hit will qualify because you don't want to unnecessarily miss that one hit, right? So for example, are the Visa credit card numbers are the only thing that is stored in a column? Or in addition to Visa, are there other credit card numbers like Amex, MasterCard, and or other sensitive data is stored in the same column, right? Or is the data incidental? Meaning, oftentimes there could be an occurrence of a credit card number in the comments field or a notes field or a documents in your database tables, right? So if there is one hit in a sample of 2000 records, would you consider it as a valid hit or is it a noise? So it is possible to store a credit card number in a column that is not a credit card information, right? So if that is not typical and not consistent with how data is stored, or if the sensitive data dominates the column, then you can leverage this hit percentage in the rule criteria to eliminate the noise. Right. So how to calculate this is hit percentage. For example, out of 2000 rows sampled, if 1000 were a match, then the hit ratio is 50%. So if you had specified the hit ratio as 80%, then there'll be no match. But if you had specified lower than 50%, then it'll be a match, right? So what are some of the valid options that you can pass to the hit percentage filter is the first one is empty. You don't have to specify anything and that is not a condition. Even one hit will match. If the value is 0, again, basically this will cause the rule to fire and you're setting the lowest bar, right? 100 means that you're setting the highest bar, meaning that means I want all the data to be matched in the sample rows. And then n could be a value between 0 and 100, and that's just the percentage that must match for the rule to fire and return results. Okay. So all the things I talked about until now, if you understand the data, you can optimize the search results better, right? So let's talk about how we handle multiple rules. So the goal is to find sensitive data, but what will you determine once you find the data, right? So the questions you need to be asking are, do you just need to identify the table with sensitive data, or do you need to find both table and columns, or do you also need to distinguish the kind of sensitive data? And will there be a security policies created to protect this data, or will there be any security alerts or some other actions taken on once you find the sensitive data, right? So you can specify any number of rules in a policy. And a policy is nothing but a set of rules, as you saw in the demo, and you can have one or many rules, right? So now the question is, what do you do once I find a match, right? So for example, if I had a table that had columns for storing Visa, Amex, and MasterCard, is it important for me to know that the table has Visa, Amex, and MasterCard in it, or just knowing that this table has credit card information in it, right? So only you know what you're trying to get at, and you need to talk to your application owners, and you need to see different protection schemes because some of them may be critical and some of them may be highly sensitive. So you may want to know the differentiation, right? Another thing to consider is the efficiency and the speed of the execution based on the options you're specifying, right? So let's take a look at this continue on match. So essentially what we're saying is we're going to evaluate the next rule in this policy, even if the previous rule is matched. So there are different kind of sensitive data and each will be identified. So therefore more than one rule can match a column, okay? The second option is one match per column. So for example, I just need to know if a column has a sensitive information, but I don't need to know each and every kind of sensitive information. Then you can choose this option. So when evaluating the rules, only the first type is found and no other rules will be evaluated on this column when you select one match per column. So don't worry about it. I have some concrete examples that I'll be talking in the next slides to understand these two concepts. Okay. So let's dig into it. Now, I want to illustrate the continue on match and one match per column with some concrete examples here so that you can understand better. So for this example, I'm taking two database tables, a table called ABC, and it has two columns, and the column one has MasterCard information, and column two has Visa credit card information. And for my table two named MNO, column one has all the sparse data. It has MasterCard in it, it has Visa and Amex. And for column two, it is just a string field. Okay. And I've defined three policies, and all the policies the rules are same, which is my first rule is find MasterCard and my second rule is find Visa. However, there are slight differences with how I choose this continue on match and one match per column. So for policy one, I've not set continue on match nor one match per column. And for policy two, I've said, okay, continue on match, but not one match per column. And for policy three, I've selected both continue on match and one match per column. And let's see for these two database tables, how are we gonna see the results when the classification policy is run, right? So for the first policy, I'll be considering table ABC, and let's see how the rule is evaluated. So when the first rule is evaluated, which is find MasterCard on table ABC for column one, MasterCard is a match as shown in green color here. MasterCard is a match. Now, the classification process moves on to the second column, looks for the MasterCard information, and it won't find any MasterCard information. Done. The rule one is done. Now, the classification process will go to the second rule. And now, will the rule two be evaluated? No, because the continue on match is not selected. So the rule two is not evaluated. So if you see the summary of the matches found, only rule one, find MasterCard, was able to find on table ABC for column one. Okay. Now let's consider policy two, where continue on match was selected. The same thing, classification process will evaluate the first rule, goes to the column one of table ABC, and it will find MasterCard. And again, it goes to column two and finds MasterCard. No, it cannot find any MasterCard information on column two. Now it will go to rule two. Now is rule two evaluated? Yes, it is, because continue on match is set to true. Now find Visa rule is evaluated, and it goes and searches in column one. Visa is not found in column two. And next it goes and finds in column two. And yes, Visa can be found in column two. So the summary of the matches found would be for rule one, find MasterCard. It did find in table ABC, column one. And for rule 2, find visa, it was able to find again in table ABC and column 2. So in this particular example, what I'm trying to say is if we are more interested in the kind of sensitive data in the table rather than just finding the table has a sensitive data, it is more of finding different kinds of sensitive data within the table. Now let's evaluate the same policy too on our second table, which is MNO, because if you remember, the data was sparse data because the column 1 had all sorts of credit card information, right? So considering this example where continue on match is set at true, when the rule 1 is evaluated to find MasterCard, column 1 did have a match, so the rule will get triggered. Okay, it will find a match. Sorry. Now the classification process will move on to second column, and it cannot find any MasterCard information there because there's just a string fields. Now rule 2 is evaluated because continue on match is set to true, and again on column 1 it can find the Visa credit card information, and when it moves on to column 2, it cannot find any Visa credit card information. So you can see the summary of the matches. Rule 1 actually triggered the table MNO with column 1, and rule 2 also triggered the table MNO with column 1. This is also an example of finding different kinds of sensitive data in a table. Okay. Now let's consider the third policy where we had selected both continue on match and one match per column, right? So it's the same thing, and we are considering the table MNO here. So again, rule 1, find MasterCard hit was found in column 2 and no hit hit was found in column 1 and no hit in column 2. Now rule 2 is evaluated. Now see the difference here when I selected the one match per column. And the rule 2 on column 1 is not evaluated because we said one match per column, and column 1 was already matched as per the previous rule. So the classification process will just skip this column 1 and it won't find anything there. So the summary of the matches would be on rule 1, only MasterCard was able to find on table MNO column 1. So I hope these concrete examples gave you a better understanding of continue on match and one match per column criteria. Now let's quickly talk about the key concepts of our run options here. So it is not important for us to find every single instances of data in a particular column, right? We just need to know if the table and the column has sensitive data, right? So we don't have to read the entire table rows. We could just take a sample set. So that is where the sample size comes into picture, which is the same size allows you to fetch the maximum number of rows that we should be looking at, right? So by default, we set it to 2000, but you can set it to whatever you want. And I think the absolute maximum number is 100 million. But no, as the sample size increases, there is a trade-off with the performance. So the larger the sample size takes, it takes more time and affects performance. Right. So in theory, if the column has only credit card information, you don't need a larger sample size. But if your data is sparse, then you will need a higher sample size. The second option is the sample type, and with the class. Within the classifier, we have a couple of options. We could read the data sequentially or completely randomize the sample set. So the random sampling is more representative results, whereas sequential will be much more faster. So we default it to random. And in the random sampling, essentially what we're doing, or what classifier is not randomizing the samples, but the classifier is asking the database to randomize it. So it uses the rand argument or the sample function depending on the databases. I know Oracle does it in a different way compared to MS SQL. The same thing with the sequential too. It is not the classifier choosing the samples, but given by the database itself. Now, I did talk about how we can improve the accuracy of the results and how to improve the performance. Let me go back to our demo and talk about in spite of I've been logged out. Give me 1 second, let me log back in. So let me talk about, in spite of fine-tuning our search expressions and utilizing the advanced rule criteria that we talked about, we could still end up with false positives, right? So how how are we going to manage this false positives here? So taking this previous example, right? This policy number. Now I know this is a false positive here, right? So what we can do is you have multiple options here. You could have add to a group of objects or object field, or you can add the entire table to exclude, or you can add a combination of table column tuple to exclude. So for this demo, let me choose this option here. So I'm going to say exclude personal policy number. Okay. And oh, I think I'll have to create a group here. So let me create a group that says exclude personal policy number. Okay. And I'm going to leave it as a group category as sensitive, and I'm going to create that group here. So now for the next classification run, what I can do is in the what to discover part for my rule, I can go to my advanced rule criteria here, and I can say exclude table column option here, and I can select my exclude personal policy number group that I just created. And if you remember, I was talking about the group which will be used in other parts of Guardium application. This is like a security policy here, right? So let me save this rule, and then let's run this discovery again. So you can see there were 2 matches found before, and when I click on run now, we should just see only 1 match found once this process is run. So let's give it a minute to see the results. Or while it is still running, I can quickly show how a group builder looks like. And the group that we just created was exclude policy number, policy or personal. Exclude personal policy number. And if I edit this group, you can see the members that it added. So it added a combination of personal and a policy number. So if you had like hundreds of those false positive, you could have just multi-selected those things, and all those table column tuple combination tuple would appear here. Okay, so let's go back to our classification process. And we can see the results now. Only 1 match found, 1 match is found, right? So it eliminated that false positive. Now the second question is, what do you do once you find this sensitive data, right? As I was saying, we pre-populate the group. We can create some alerts on this sensitive data, or you can create some access policy rules. For this demo purpose, I'm not going to create anything because that is beyond the scope of discovery of sensitive data. But these are all the options that you can do. You can create an alert, and if your SMTP and SNMP configurations are set, you can also send email notifications too. Okay. So, or I can just pick alert on access to the sensitive data. And this is what it looks like. You can create a policy and take some further actions on it. So the next thing I want to quickly talk about is the auditing part here, right? So you can define receivers for the results of what you just discovered. So you can define any number of receivers and send the results to the Guardium users. And I was saying, if you have the SMTP configurations or SNMP configurations, you can email the results to whoever is reviewing, right? So for example, I can say within this Guardium and Guardium, for everybody who has the audit role, they can review this results. Or I can also add a receiver saying for all the admins, I want them to sign off on these results, right? So this is how you're tying up to a compliance workflow. And this audit process is not doing anything until you schedule it, right? So ideally, you can run this entire classification process like nobody runs once a day, but at least you can run like every 15 days or every month. But again, you can also select if you want to run it on the first day of the month, last day of the month, or you can also select first Monday or first Sunday of every month, and you can activate the schedule. So I think this is how the entire discover sensitive data scenario is tied to a compliance workflow. So now with the schedule, it's going to run every month and sends the results to the roles, or you could have also selected the individual users. So this is how you're tied to a compliance workflow.